Chapter 3, Lesson 8. Our learning objective is that you will identify and analyze the relationship between points on a coordinate plane. So we're talking about ordered pair relationships. The four regions of the coordinate plane that are separated by the x and y axes are called quadrants. Quadrants are numbered with the Roman numerals 1, 2, 3, and 4. If you know the signs of the coordinates of a point, you can determine the quadrant where the point is located. So over here, it shows you a little cheat sheet. So it says that if the x-axis is positive and the y-axis is positive, it's in quadrant 1. So if it's negative, it's quadrant 2. Or sorry, negative, positive is quadrant 2. Negative is quadrant 3. And positive, negative is quadrant 4, right there in that graph. So unlock the problem. The point -3, 4 represents the location of a bookstore on a map of a shopping mall. Identify the quadrant where the point is located. Okay, so over here in the little blue box, it says the x-coordinate of the point. What is it? And so the x-coordinate is the first number, which is -3. And then the y-coordinate is the second number in that ordered pair, which is 4. Remember that it's always x, y. So find the quadrant that contains -3, 4. So first we're going to examine the coordinates. The x-coordinate is -3. So the point is 3 units to the left of the origin. Since the point is to the left of the origin, it must be located in either quadrant. If we look up at the top again, to the left means that it's going to either be quadrant 2 or 3, which is written as II or III. Step 2 is to examine the y-coordinate. The y-coordinate is, we know it's 4, which means it's 4 units up, because it's positive, up from the origin. So since the point is above the origin, it must be located in quadrant 2 because quadrant 3 is below the origin. So by check by graphing the point -3 on the coordinate plane. So we start at 0, go left -3 and up 4, which is right here. And that is indeed in quadrant 2. So the point representing the bookstore is located in quadrant 2. A figure has line symmetry if it can be folded about a line so that its two parts match exactly. If you cut out the isosceles triangle at the right and fold it along the dashed line, the two parts would match. So again, right here where it's dotted, if I cut right along that, or if I just folded it up, the right and the left side put together would match. A line that divides a figure into two halves that are reflections of each other is called a line of symmetry. You can use the idea of line of symmetry to analyze relationships between points such as 5, -1 and -5, -1, whose coordinates only differ in their signs. So looking at this activity, it says identify the lines of symmetry in the rectangle. Okay, so we're going to look over here at this rectangle to the right. And looking at that, it says the blank axis is a horizontal line of symmetry. So if we're looking at horizontal, that's going to be the x-axis. And the blank axis is a vertical line of symmetry, which is y. Look at points A and B. What do you notice about the x-coordinates? What do you notice about the y-coordinates? So we're looking at A and B. So what do we notice about those? We notice that the x-coordinates are the same. They're both 5. But the y-coordinates, one is 4 and one is -4, which means that the y-coordinates are opposites. Point B is a reflection of point A across which axis? So B is here, A is here. So they're flipping over this what axis here? And that would be the x-axis. And how do I know that? Because if you fold the rectangle about the x-axis, or across the x-axis, point B and point A will line up with each other. So looking down at points A and D, what do you notice about the x coordinates? So if we look at point A and point D now, okay, what do we notice about them, about the x and the y coordinates? So the x coordinates are 5 and -5. So the x coordinates this time are opposites. They're the same absolute value, but different signs, so they're opposites. And the y coordinates are 4 and 4. So they're the same. So point D is a reflection of point A across which axis? So D is over here. We have to cross the y-axis to get to A, which means that they're a reflection across the y-axis. And how do you know? Same reason. If you fold the rectangle about the y-axis, or you fold it at the y-axis, points D and A will line up. And moving down, says which point is a reflection of point B across the x-axis and then the y-axis? Okay, so looking up here, it says which point is a reflection of point B. So we're looking at B, but we need to go across the x-axis. So this one's across the x-axis, so now we're at A. And then we're going to go across the y-axis, which is point D. So point D, to get from B to D, you go across the x-axis and then across the y-axis. So compare the coordinates of point B with the coordinates of point D. So if you look at B and D, the x and y coordinates of point B are opposites of the x and y coordinates of point D. So both the x and the y are opposites, because if we look at point B, it says that it is 5, -4, and B is 5, -4, and D is -5, 4. So 5 and -5 are opposites, 4 and -4 are opposites. which means both the x and the y coordinates are opposites. Again, our learning objective for today's lesson was that we will identify and analyze the relationship between points on the coordinate plane. And remember what those quadrants are. Make sure that you remember to reference this page if you're not sure of which quadrant is positive, positive, negative, negative, and so on. If you have any questions, please ask your teacher.